Hello everyone, I welcome all of you to Startup Academy, India's exclusive coaching for ISS examination. So we'll be continuing with the series of Statistics Paper 2, Solvation of PYQ 2026. In the previous lecture, we solved questions 1 to 10 and today we'll be taking questions 11 to 20. And previously we have done official statistics questions. So if you haven't done that, you can first watch these two videos, then you can come back to this and watch this one. So we'll be taking series A, as you all know, we'll be taking series A, and the questions might be shuffled for B, C, and D. You can consider, you can see that then and there. So first of all, we'll be seeing question number 11. Question number 11 states that if 95% confidence interval for mu with z alpha by 2 is 1.96 is 407.84, the sample size is large, the value of standard error of mean will be. Now, first of all, the value of standard error of mean is equal to margin of error upon z alpha by 2. First of all, we have to calculate margin of error. I am writing it as ME. Margin of error is equals to upper limit minus lower limit upon 2. The upper limit that has been given to us is 407.84 minus the lower limit is 400 upon 2, which will give us 7.84 upon 2, which is equals to 3.92. So we have got marginal error. Now we have to put it in standard error formula. Standard error is equals to marginal error, which is 3.92 upon z alpha by 2, which is 1.96. Clearly, this is divisible by 1.96 and your final answer will be 2, which is our option number A. If you knew the formula, this is an easy question. We will be considering it under easy one. Now, the second question, 12th. 12th question is the statement of our Neyman-Pearson factorization theorem, the basis of our sufficient statistic. As you all can see, Neyman-Pearson factorization theorem states that ft given theta is equals to g t x theta into hx. So the statement states that when we have xi is random variable from a distribution with PDF of PMF fx theta, a statistics t is said to be sufficient for theta if the conditional distribution of x given t. So here it is, they have taken x given t. So we will be considering this x given t. When the function PDF of x given t is, it is always independent of theta, which is our option number B. This was our theorem, Neyman factorization theorem. This was the very basics of sufficient statistic. So it was an easy one. Now moving forward towards another question, which is our question number 13. Question number 13 gives us, let xi be a random sample from distribution f theta for which mean and variance exist. Mean and variance be, let mu and sigma square be the mean and variance of the distribution. Then the unbiased estimator of sigma square. We all know this, whenever mu and sigma square of a distribution are given, then the unbiased estimator of sigma square is s square, which is equals to 1 upon n minus 1 summation I goes from 1 to n xi minus x bar square. The denominator should be I minus 1. This should be kept in mind, and this also has been the part of your sampling. No derivation is required for this. This was just a theoretical portion. So option number C is the correct option for this question. Now moving towards another question, which is question number 14. This is again the direct statement of Neyman Pearson lemma, NP lemma. They have given us the direct statement of NP lemma. The basis of NP lemma is that we take simple H naught versus simple H1. What is simple? Simple means that our values are provided. If we say that sigma H naught is equals to sigma naught is equals to sigma naught is equals to sigma square. This is a simple H naught. And if I say that H naught is equals to sigma naught is greater than sigma square or less than or not equal to, then we will say that it is composite. So the basis of NP lemma is simple H naught versus simple H1, which is our option number C for this statement. This was also a theorem. They directly asked you the theorem. Now moving towards another question, which is our question number 15. First of all, they have given us that xi's follow normal distribution with mu and theta as mean and variance, and mu is known. Whenever mu is known, then the sufficient statistic by factorization theorem will be equal to summation xi minus mu whole square, where I goes from 1 to n. So let us take it equal to t. So this will always be sufficient for mu, when mu is known for normal distribution with mean mu and variance sigma square. So it will be always be sufficient for variance, which is sigma square, or we all can say sigma square. This theorem we have done multiple number of times, so it is also a theorem. Then the next, that this means that the first statement is correct. Then the next statement states that S naught square is equals to, they have given us S naught square is equals to 1 upon n summation xi minus mu whole square. Now if you see this clearly, this is nothing but 1 upon n into t. T was our sufficient statistic. So we can say that S naught square is a 1-to-1 function of t, or 1-to-1 function of a sufficient statistic, right? If we say that S naught square is 1-to-1 function of t, then it also is a sufficient statistic. Any statistic which is a 1-to-1 function of the sufficient statistic is also a sufficient statistics. This is also one of the theorems. So hence statement 2 is also correct, and option number C is correct option for this, that both statements are correct. These the questions that we have been doing from 12, 13, 14, 15, most of them are direct implementation of your laws and theorems. Now again another law has been asked in question number 16. Question number 16 says that we have been that T not be the MVU, minimum variance unbiased estimator, NVUE. T naught has been given of gamma theta. They have given this. And T1 is unbiased estimator with efficiency E theta. So T1 is another efficiency. It is not MVUE, but and has it is unbiased estimator, and it has efficiency E theta, which is less than 1. So which of the following statements are correct? So first of all, they have given us in first statement they have given us U is equals to a linear combination of these two, which is A naught T naught plus A1 T1, and A naught plus A1 is equals to 1. and they have said that this is MVUE. Now, first of all, if you would have learned the theorems of MVUE, minimum variance unbiased estimator, it says that MVUE is always a unique statistic. Hence, if they have already mentioned in the question that T naught is the MVUE of this, then no other statistics exist. Either it may be a combination of other statistic having less efficiency, or having more efficiency, or it is another statistic having less variance than this. If they have mentioned one statistic as UMBUE, then it is unique and no other statistics exist of the same variable that may be MVUE for this. So statement 1 is wrong because we know that no other statistic exists. It may be a linear combination, it may be another statistic, no other exists if one has been mentioned. Now the second statement also states one of the linear combination, which is V is equals to A naught T naught minus A1 T1. Another statistics they have given, which is again the linear combination, so it will always also be wrong. And hence our option number D is the correct option for this question, that neither of the statement is the correct statement. Now here in question number 17, they have asked us, they have given us that xi's follow normal distribution with mean mu and variance sigma square, and they have taken theta is equals to sigma square for calculating purpose. And they have asked us to calculate the value of I theta or Fisher's information. So first of all, let us see what is fx theta. If we say that we are considering xi follow normal mu sigma, in place of sigma square let us take theta. So it will be 1 upon under root 2 pi theta exponential minus x uh, minus mu upon theta 2 theta whole square. This is the PDF of our normal distribution. Now, in solving this, let us take log of this f x theta. So, while taking log, it will be minus 1 upon 2 log of 2 pi minus 1 upon 2 log of theta minus x I minus mu square upon 2 theta. Okay. Now, before taking log, let us they have also taken xi. But here we are not taking xi because we have to only get the e theta for log. We don't have to get it for n number of sample. We have to get for one number. So that is why we are taking this. Okay. Now we will differentiate this with respect to theta one time. If we differentiate this, this term will be equal to 0, second term will be equal to 1 minus 2 theta, and the third term will be equal to plus summation xi minus mu whole square upon 2 theta square. Okay. Now again we have to take double differentiation. Ln f x theta delta theta square is equals to minus, now this will be plus 1 upon 2 theta square minus summation xi minus mu whole square upon theta cube, because 2 will get cancelled by 2. Now here we have to find the expected value of this last one. So if we have to calculate the expected value of this, then we have to calculate the expected value of this. So I am calculating it. this will be nothing but equal to 1 upon 2 theta square, and this will be equal to minus, if I calculate the expected value of xi minus mu whole square upon theta cube. Now expected value of this will be nothing but the variance, so it will be 1 upon 2 theta square minus variance as the value theta upon theta cube. So it will be 1 upon 2 theta square minus 1 upon theta square, which will give us the answer as minus 1 upon 2 theta square, which is our option number A. So this was the direct implementation of your Fisher information. I hope that it is clear. Now moving towards question number 18. This is the question of CR lower bound, and they have given us S naught that xi follows normal distribution with mean mu and sigma square. They have given us. So let us take this as xi minus mu upon sigma follows normal distribution with standard normal distribution. If I square this term, xi minus mu upon sigma whole square, it will be following chi-square n distribution. Now let us take this as equal to y. Suppose I am taking this equals to y. So expected value of y will be equal to n, and variance of y will be equal to 2n, because it follows chi-square distribution with n degrees of freedom. So expectation will be n and variance will be 2n. Okay, we have found out this. Now moving towards what they have asked in the question. First of all, they have said that x naught square, they have given us s naught square is equals to 1 upon n summation I goes from 1 to n xi minus mu whole square. If we see this clearly, then xi minus mu whole square can be converted to 1 upon n by sigma square, right? Now this can be written as sigma square upon n y is equals to s naught square. If we want to take the expectation of this, expectation of s naught square will be equal to sigma square by n expectation of y, which will be equal to sigma square. And if we want to take the variance of this, variance of s naught square, it will be equal to sigma square whole square upon n square variance of y, which will be equal to sigma square whole square 2 times upon n, because we have put the variance of y equals to 2n. Now we have calculated this. To calculate the CR lower bound for CR LB, we have to calculate the Fisher's information. The Fisher's information is minus expectation of theta delta f ln f x theta upon delta theta square. Okay, so this is it. Now here we will be calculating it under the sample size n. So there is one similarity between this question and the question number 18. In this question also they have given us normal distribution, and previously also they had given us this, and there also we calculated the Fisher's information. Here also we calculate Fisher's information. Previously the value of Fisher information came as minus 1 upon 2 theta square, but here we are calculating for n terms, so it will be minus n upon 2 theta square, but minus sign will get cancelled with this and this will be positive. N upon 2 theta square will be the answer for Fisher's information of this. Now, if we have to calculate the lower bound, CRLB, CRLB, Cramer law lower bound has the formula 1 upon I theta, which is equals to 2 theta square upon n. Okay. Now theta here is nothing but equal to sigma square. So we will be substituting it to sigma square whole square upon n. Now if we see this clearly, this information which is CRLB and this information which is the variance of S naught square. Both of these, let me take it in one frame. Both of these are exactly equal. So the statements, let us read the statement. The first statement says that variance of S naught square is more than CR lower bound. No, they are equal. So first statement is wrong. Second is variance of S naught square coincide with CR lower bound. Yes, they coincide. That is why they are equal. So second statement is the correct statement. S naught square is the MBB estimator of theta, minimum variance bound estimator of theta. Whenever here you can see that the expectation of S naught square is sigma square. So which means that it is an unbiased estimator. Whenever an estimator is an unbiased estimator and also coincide with CRLB, then it is MBUB. So it is coinciding with CRLB and it is unbiased. Two of the necessary conditions are fulfilled and hence we can say S naught square is the MBB, minimum variance biased estimator of theta. Hence statement 3 is also correct. So we can say that statement 2 and 3 are correct and hence option number C is the correct option for this question, which states that statements 2 and 3 are correct. I hope that this question is clear with all of you. Now moving towards another question, which is question number 19. Question number 19 has given us that a batch of 19 students is examined into the three subjects: statistics, which is X1, mathematics X2, computer programming X3. And it has been given that the partial correlation coefficient of statistics and computer programming on mathematics is 0.6. And it is expected that X2 will be affect the correlation between X1 and X3. The value of test statistics for calculating the test under H0, rho 13.2 is equals to 0 and against H1 it is not equals to 0. So first of all, to see this, to calculate this, we should know the basis of this question. If we calculate, if we are talking about any partial correlation, suppose it is 1, 2, not 3, 4, 5, 6 up till k. So it will always be following t statistics when n minus k minus 1 degrees of freedom. This is very important concept. This might haven't come in the exam previously, so this is a new kind of concept that you might be learning. So it is partial correlation coefficient always follow t distribution with n minus k minus 1, where k is the one which is affected. Now here the affected part, which is only k is equals to x2 only, because x2 will only affected, which is mathematics. So x2 is only one part. So we can say that, and n is equals to 19. So we can say that R13.2 will be following t statistics with 19 minus 1 minus k will be the value that will be affecting. So it will be x1 and x3. It will be equal to 2. So it will be k minus 1 minus 2, which will be equal to 16. Now we know the relationship between these two. If we have to calculate t statistic, then it will be equal to R 13.2 into under root of n minus k minus 1 upon under root of 1 minus r square. This is the formula for calculating t statistics when we only have partial correlation coefficient. Okay. This exact formula came in one of the questions in paper 1 as well. So T statistics has the value, R13.2 has the value 0.6, under root of 16 upon under root of 1 minus 0.6 whole square, which is equals to 0.6 into 4 upon 0.8. And on cancelling terms, we will be getting our final answer as 3, which is our option number B in this case. A new concept came this time, which was unexpected. So those who would have done it might have found this easier. Otherwise, it was a hard one. Now, question number 20. Question number 20 is again the implementation of our law, one likelihood ratio test. What they have used here is likelihood ratio test. Okay, so the likelihood ratio test is the ratio given to as maximum of L theta phi upon, it will be L of the parameter theta naught upon maximum of all the L's, which is parametric, where phi is equals to parametric space, which is our option number A, direct implementation of our theorem. Okay, so this was all for today's lecture. I hope that you understood the concepts in detail. We have done it in very detail for all of you, especially for all of you. If you are still facing any doubt in any question, then you can ask us in the comment section or on our WhatsApp channel. We'll be answering you then and there. All the best. Thank you.
Welcome to StatUp Academy, India's exclusive coaching for ISS, where statistics meets excellence. StatUp Academy,